Hey guys, welcome to my channel. Today, we will be talking about rate of reactions. In this video, you will be able to follow up on successful collision theory as well as the factors affecting the rate of reaction. At the end of this lesson, or at the end of this video, you must be able to describe the effect of certain factors on the rate of reaction. You must be able to explain the effect of catalyst that accounts for the increase in rates of reactions. You must be able to suggest a suitable method for investigating the effect of a given variable on the rate of a reaction, as well as to interpret any data or graph given to you. So the first one, successful collision theory. In order for a reaction to occur, every particles must collide and overcome the activation energy. When they do this, this is called the successful collision. You can increase or decrease the speed of the reaction while playing with the frequency of the collision. So for example, if you want to increase the speed of the reaction, you can first increase the frequency of collision, and then this will increase the frequency of successful collision. When that happens, you can increase the speed of the reaction. If you need to decrease the speed of reaction, everything else will work the same way. You decrease the frequency of collision, decrease the frequency of successful collision, therefore decrease in speed of reaction. There are 5 factors affecting rate of reaction: concentration, pressure, temperature, particle size, and also catalyst. The first one is concentration. Let's talk more about concentration now. If you look into the diagram, the left-hand side, you only have a few molecules. Therefore, you can only get a few collisions. But once you increase the concentration, which means that you are adding in more particles into that specific rectangle or specific beaker or container. So when you have more molecules, the particles are getting closer together, so you are expecting more collisions. If you want to explain this in steps, the first things first, particles gets closer together, therefore more collisions of particles. Once that happens, this allows more successful collision, therefore there will be an increase in rate of reaction. If you want to interpret any data or draw any graph, so you will have this graph. When you compare this set of graph and the other one, if you increase the concentration, you will find out that this graph has a steeper gradient. So a steeper gradient in graphs is showing you that the concentration has been increased, right? Next one. For pressure, this is for gas particles only. If you imagine holding a syringe and putting your thumb at the end of the syringe, and when you push down, you're basically increasing the pressure inside the syringe. And if you look into the particles in this diagram, they are getting closer together. So if the question is asking you to explain, you should be able to say that the particles are squeezed closer together, more collisions of particles, allowing more successful collisions, which results in increase in rate of reactions. Right? I hope that's quite straightforward. I need to clarify as well in this one that pressure has no effect on liquid and solid molecules. Again, this is only for gas particles, and you need to bear that in mind because this always comes out in MCQ questions. Right, for temperature, if you are increasing the temperature in a reaction, what happens is you are actually increasing the kinetic energy of the particles. So, first of all, the particles will gain kinetic energy, resulting in more collisions of particles, allowing more successful collisions, and in the end, there will be an increase in rate of reactions. The graph looks exactly like what you saw just now. If you increase the temperature, obviously, because the rate of reaction increases, the gradient of the graph will be steeper once you increase the temperature. However, it levels off on the same axis as the lower temperature. Next one, you're talking about the particle size. So for example, if you use a magnesium strip versus a magnesium powder. So if you look at the magnesium strip, it says the acid ions can only collide with outer atoms and not with those within a large lump. But if you break this magnesium strip or you use magnesium powder instead, if you look at these red circles, they can actually collide more with the surface of the magnesium powder. So with a powder, there are more surface particles, so there can be more successful collisions. If you can't see it in this diagram, you can have a look in this one. So you are reacting magnesium and acid. So if your magnesium is in lump, or you're using a magnesium strip, this is only giving you a low surface area for the red molecules to react with your magnesium strip. However, if you are using magnesium powder and you're breaking down the magnesium strip, the red circles or the red molecules, which are your acid particles, can react with the magnesium powder. So a higher surface area. If the question is again asking you to explain, then you should be able to say that the surface area increases, more collisions of particles on the surface, more successful collisions, increase in rate of reactions. So if you're seeing this explanation bit of all the factors affecting the rate of reaction, they are actually the same towards the end. You are talking about the frequency of collision, and you are also talking about the successful collision. So the last factor affecting the rate of reaction is your catalyst. If you look at this diagram, what happens is catalyst provides alternative pathways with lower activation energy for the reaction to occur. So this graph in blue is showing the activation energy without a catalyst, whilst the red one is showing you the activation energy with catalyst. So the catalyst actually lowers down the activation energy. Therefore, when activation energy is lowered, more collisions of particles can occur, more successful collision that can overcome the activation energy. Therefore, there will be an increase in rate of reaction. And if you plot this into a graph, volume of hydrogen against time, when you're using a catalyst, the gradient is steeper than when you don't use any catalyst in a reaction. Summary. Every particles must collide and overcome activation energy for a reaction to occur. There are 5 factors affecting the rate of reactions which you need to be able to describe and explain in exams. The first one is concentration, in which you will talk about the space between the particles, whether they are closer together or far apart. For pressure, again, tell yourself this is for gases only. So you are also talking about the space between the particles. Temperature is another factor affecting the rate of reaction. You will be talking about the kinetic energy of particles. If you are increasing the temperature, kinetic energy increases. However, if you are decreasing the temperature, kinetic energy of particles decreases. If you're talking about the particle size, the surface area of the particles will come into the explanation bit. Okay, so you're going to be talking about the surface area. If your particle size is big, then you will have a low surface area. If you have a smaller particle size, for example, your magnesium powder, you will have a higher surface area. More collision can occur on the surface. This will increase the rate of the reaction. The last factor affecting the rate of reaction is your catalyst, in which in your explanation you must be able to talk about the activation energy. So if you're using a catalyst, again, this will lower down the activation energy. If you don't get any of the points, please feel free to replay the video and watch it as much as you want to. I don't really mind. Good luck!